Hey everyone, and welcome to The Explainer. Today, we're evaluating something that is so deeply woven into the fabric of our everyday lives that, well, we kind of take it completely for granted. Yep, we're talking about salt. Imagine a material so absolutely vital that ancient empires literally rose and fell just to control it. Yet today, most of us just see it as that basic, mundane shaker on the dinner table. So in this explainer, we're going to strip away all that modern complacency and really contrast its empire-building history with how we view it today.
Okay, so let's dive right in by asking our central question for today's evaluation. Is this humble little crystalline mineral the ultimate S-tier foundational material of human civilization? Or, despite its massive historical run, has it kind of just devolved into an overlooked necessity? Well, we are going to judge this building block with zero mercy.
To figure that out, we've put together a definitive dossier. We'll look at the historical foundation, its engineering superpowers, the massive modern salt machine, the corrosive costs, and finally, we'll give our final verdict.
Starting off with Part 1, the historical foundation scaling human civilization.
To truly grasp how this surprisingly complex material scaled scattered tribes into massive global empires, we have to look at what it actually is. I mean, before it's a French fry seasoning, it is sodium chloride, or NaCl. Whether it's harvested from evaporating seawater, dug straight out of ancient underground rock deposits, or pumped up as brine, this is the original life-sustaining, industry-enabling mineral. Think about it. Without this specific chemical compound, early humans simply could not have preserved food to survive those brutal winters. And on top of that, modern chemistry literally would not exist as we know it. And its track record over time, absolutely staggering. We've got evidence of salt production and trade going as far back as 6000 BC. By 3000 BCE, dedicated salt roads and mines were the literal fuel for emerging civilizations across the Middle East and China. Jump forward to the Roman Empire, and Roman soldiers were actually paid their wages in salt. That is exactly where our modern word salary comes from, which is just wild to think about. And it didn't stop there. By the 20th century, it became the indispensable feedstock for the massive chlor-alkali industry. We're talking 8 millennia of continuous progress.
Moving right along to Part 2, engineering superpowers, dissolving the specs.
So when you look at its dry chemical properties, it's amazing how they translate directly into world-altering superpowers. Take melting point depression, for instance. Now, I know that sounds like a super boring textbook term, but in the real world, this is what lowers the freezing point of water. That translates directly into de-icing roads, preventing economic collapse, and saving millions of lives every single winter. Then you've got its chemical reactivity. It's the raw material we use to produce chlorine, sodium hydroxide, and soda ash. Plus, it's highly soluble, which means it is incredibly easy to extract and purify. All of this makes it one of the most functional and accessible minerals on Earth.
All right, Section 3, the modern salt machine. Mapping the crystals today.
Now we're currently in the year 2026, and salt definitely isn't just some relic of the Roman Empire. No, it is an absolute juggernaut of modern industry. Just take a second and let this number sink in. 300 million. That staggering figure is the tons of salt produced globally every single year. It is straight up one of the most heavily mined and processed materials on the face of the planet.
But here's the kicker. When we break down where all 300 million tons actually go, the results might really surprise you. It's not mostly food and preservation. In fact, that's just a tiny fraction. Massive, massive chunks go directly into the chemical industry as industrial feedstock. Another huge slice is dedicated solely to de-icing our winter infrastructure. We also use millions of tons for water treatment and softening. And looking ahead, salt is now being heavily researched and used for thermal energy storage, plus next-generation molten salt nuclear reactors. So yeah, it's quite literally powering our future.
Which brings us to Part 4, the corrosive cost, no nostalgia points.
See, in this explainer, we do not give out nostalgia points, so we've got to be brutally honest here and expose its weaknesses. Let this sink in for a second. This is the ultimate paradox of sodium chloride. The very same material that kept early humans alive through brutal winters by preserving their food? Yeah, it is the exact same material that aggressively eats away at the bridges, the vehicles, and the steel-reinforced concrete that we rely on every single day.
And unfortunately, the deductions definitely do not stop at infrastructure. Salt is highly corrosive to metals the second it gets wet. Beyond that, we have to deduct some major points for its significant environmental footprint. I mean, road salt runoff actively harms soil, it stunts plant growth, and it pollutes freshwater ecosystems. Then, on a human health level, while yes, we absolutely need it to survive, dietary overconsumption is a massive issue today, linked to hypertension and heart disease. And finally, extracting 300 million tons of anything isn't a free ride. Large-scale mining and evaporation processes are still highly energy-intensive.
So here we are at part 5, the final verdict, tallying the scorecard.
We've looked at its empire-building past, its massive modern industrial scale, and of course, its brutal flaws. Let's let the numbers speak for themselves. Historical impact gets a massive 9.5 out of 10. Mechanical properties are a little basic, so that scores a 7, but workability bounds back with a stellar 9.5. Now, for scalability and cost, salt scores at perfect 10. It's incredibly abundant, insanely cheap, and that easily offsets its basic mechanical nature. With versatility at a 9.5 and lasting relevance holding strong at a 9, well, this scorecard is looking incredibly top-heavy.
Averaging all those out, we land at a massive 9.1 out of 10. Which means salt rightfully takes its place as an S-tier essential material. Honestly, the minor drawbacks like corrosion simply do not outweigh its 8,000 years of service to human progress. It really is the quiet champion that preserved humanity, built the entire chemical industry, and remains utterly vital today. If concrete built our cities, salt seasoned and sustained the people living inside them.
So it's an undisputed S-tier essential for me. But what do you guys think? Is salt a rightful S-tier, or is it just a little too basic to sit at the absolute top? I'm going to leave you with that provocative thought to answer down below. Thank you so much for joining me, and hey, don't forget to tune in for our next explainer where we're going to evaluate copper and its absolutely vital role as the red metal conductor of the green energy transition. Stay curious, and I'll see you then.